So today what we'll be seeing is we'll have a brief introduction of the memory management which is there in Python. So this is very less spoken when it comes to Python because we mainly build models and we do machine learning stuffs, but we hardly go into the internals and how the memory management happens. But when it comes to a broader picture, our major goal is to build model that is very efficient. So efficiency in terms of like how it's access the memory and how much storage and how many objects it's referring internally. So that is a major concern when we build any machine learning models. So let's understand the basic concept of how the memory management is done in Python. So memory management in Python is done with the help of two major concepts. So first thing is what we have, that is called as garbage collection. So now if you come from a Java programming background, you know what this garbage collection is. And then we have something called as reference counting. So these two are the things by which Python does the memory management. So now we want to understand what these two things are basically. So just first and foremost in Python, the memory allocation and deallocation is done automatically. So no need for manual garbage collection. Now, say for example, this is our diagram. So let us understand with the help of a diagram. So let's take one variable here. So say that is X, and I'll just change the color. That is X, and say it is referring to one memory location, and that is pointed by these two. So it is now occupying these two memory locations. Let it be of any size, and say the value of this is uh, 10. So it is basically 10. So that is referred by X. So we need to assign a reference pointer. So that will be something like this, that the X is referring to this particular memory space which has value 10. So now we do side by side coding of this. So I have a variable that is X which takes value 10, and then what I'm doing is I'm creating another variable that is Y, which again has the copy of the value which is contained in X. So somewhere here I need to create one more variable. So what I have is I have one more variable that is Y. Now Y is also referring to this same X, that which this is referring. So it looks something like this. So whenever you draw memory referencing, you have to draw this line inside this block. So this is what this particular statement is, and obviously in the memory internally it will have some memory ID that it will allocate by the Python compiler, that is it's called as the Python virtual machine PVM. And let us do one checking, like if id of X is equal to id of Y. So this is basically used to check the reference whether it's used to refer the same memory location. If it is same, then it will print X and Y refer to the same object, and we are just printing the ID whether to check whether these two are, or diagrammatically what we have drawn here, it is the same or not. So let's go ahead and just run this, and you can see X and Y refer to the same object, and you can see I have printed the ID, that is the last digits 36672 36672. So this diagram is correct. Now what I do is I just increment this, that is a value of X. I just increment this to 1. So what I have written here, that is the reference counting. So now the memory location X is referenced by two variables, that is X and Y. So X has a reference count of 1. So X has a reference count of 1 and Y also has a reference count of 1. Now when this particular statement is executed, the value of X prior when it was 10, that itself is stored in Y. So Y is also referring to the same memory location. Now when value of X is incremented, that is from 10 to 11, it will refer to some other memory location and say we denote that memory location somewhere here. So let me fill this. So now this becomes 11. So this is 11, these two blocks. Now what happens is this reference where X was originally pointing, this will get terminated. So this gets cancelled and instead it will point to new memory location. So obviously the counter of this will change and it will get a new counter that it still has reference 1, but originally it was not pointing to this one. Now it is currently be pointing to this one. So now it will be basically referring to this memory location. We'll just change the color here. So now X is referring to here, whereas Y is referring to the older place, that is this place. So this is reference counting. So whenever the reference is removed, the reference counter is decremented and the reference count when it becomes to 0, that means this particular memory is not allocated or it will be deallocated. So let's go ahead and check this. So if this is not the case, the first condition is not the case, then it will obviously referring to some different memory location. We'll just go ahead and run this. You can see it is referring to different objects and you can see the ID just to make sure like everything is correct. It is different. So originally it was referring to this one. So say for example this X, the address of this X was this thing. Now for 11 it is getting this address. So that is the basic memory management concept in Python. And obviously if you just deallocate this X or deallocate Y, so basically that memory allocation will not be there. So see, when we have removed Y does not exist in the memory and it said like name Y is not defined. So Y basically is not referring and we are just saying like what is the ID of Y. So basically Y doesn't exist, it is 0 and therefore it is not there. So well, that was a quick and brief introduction of memory management in Python. So hope you guys enjoyed this video. If you found you got educated from this video, please do like, share, comment, and if you're new to this channel, please consider subscribing. Thank you very much for watching this video.